Greetings of the day to viewers of this video and welcome back to ptscadexpert and myself architect Kumar Kapadia from the city of Surat in Gujarat. And for this course, Master Diploma in Revit Complete BIM course, which is a combination of architecture plus structure plus MEP. For architectural segment, if you just go to ptscadexpert channel on YouTube under Revit BIM playlist, we have enlisted a lot of live project tutorials which follows the modeling of a particular residential structure with all the details. For example, if you just talk about this particular project, then this is G+2 residential villa which follows the level of detail 400, which showcase the modeling of a particular project exactly the way the structure is elevated on site. That is, how is a column elevated from footing and joined to beam and floor, and all how are all the structural elements joined to the architectural element wall with its wrapping layer, inserts and joint condition. So if you want to enhance your modeling skills with Revit, then kindly enroll for this particular course, the next batch of which is going to begin from first week of February. And let's learn together and let's grow together. But for today's exercise, we are just going to elevate this particular simple G+2 residential villa in Revit, which will not take into consideration the structure part, and we will just learn that how quickly and efficiently you can create a architectural presentation model in Revit in stipulated time frame. So while going to file, let's click new and project, browse, and we are going to model this particular project in imperial system, so English imperial, and therein I'll just go to the particular default architectural template and open and OK. So the first step that follows is that the creation of levels while going to the elevation. So herein I'll just create this couple of levels, and I'll call this ground road level, ground road level. Then we will have a plinth of 18 inches, so plinth level. And then while clicking LL, I'll just hover 10 foot and I'll create one level, and I'll call this first floor, and then LL, and I'll just pick lines, and with 10 foot of offset I'll create one more level. I by mistake created that particular level here. I'll just click undo and LL, and let's create that particular level at 10 feet height, which would be slab top. And this newer version of Revit, if in order to make this particular levels, enlist this particular levels in the project browser and make that levels authentic, you need to go to view tab and then plan views. For all the categories, you have to select that particular floor plan and get it this particular annotation which shows the finish unfinished turn to blue from black. So plan views and reflected ceiling plan, and the newly created levels, I'll just make them true for all the categories. Structural plan, and this category actually doesn't exist, but I have created that. Fine. Now I'll just go to this particular. Right now you see that all of this doesn't follow the levels. It's not in order. So I'll just go to this browser organization and say that by level, and herein I'll just say that for sorting and grouping, I'll say that associated level by family and type, and just click OK. And instead of all, I'll just click by level and apply and OK. And I guess that I made a mistake. Let's edit sorting and grouping. This should be by family and type, and then sorted by associated level. Sorry. So with that, now you have those particular floor plans putting up in order. Fine. So I will just go to this particular ground road level, and herein we will go to insert and import CAD, and I will just load the AutoCAD drawing of this particular project, desktop, and PTS Feb batch Web Live project. Preserve all, and if this particular AutoCAD drawing is in feet inches, then the import unit should be inch and manual center and open. And this is how we have loaded this particular AutoCAD drawing into this Revit interface. UN, and I'll just say that nearing up to 1/4 of an inch. This is precision of AutoCAD. And VG, visibility graphics, I'll just say that import categories and turn it to halftone. Now before proceeding further, what I would like to do is that I would like to go to this particular modeled project, and herein with the help of what we are going to do is that we are going to transfer certain standards from this particular project. For example, the wall types, the floor types, the materials and everything. Don't worry, I'll show you that how to create that, but I don't want to waste time, and rather I would like to focus on the modeling part. So why not use functions and features of Revit and transfer the standards from this particular project to the newly created project which doesn't have any details. So I'll just go to this particular manage tab, and herein you have this particular transfer project standards. So that particular project is open, live project, fab batch, check none, and from that I'll just say that I would like to select wall types and floor types. Where are the floor types? And yes, and I would like to also select the materials, and that's it for now. Yes, and overwrite. We will copy as and when needed during the modeling part. For example, right now I have not copied the door windows and the openings, which if you can see that all of this are the parametric stuff which has been loaded over here. So that we will load once we complete with the solid modeling part of this particular structure. Fine. Also, I would like to say that go to manage, and let's see that whether I can transfer the curtain wall types. And yes, curtain wall types here. That also I will just transfer and overwrite. Fine. So let's start. So first is that I will just go to architecture, and herein I'll just say that floor architecture, and you see that all the floor from that particular project has been copied with that particular one function. So we don't waste time on creating that, but how to create that I will just show you. Fine. So first is that I would say that entrance pathway and just drafting tools, and I will just say that pick lines. With this I will just draft, select this particular, and complete it. Yes, here this is left. So pick lines and TR and join this to this. Okay, and here too I would just say that LI and LI again and pick lines. Okay, and you see that this is just a floor, simple floor of 6 inch which has been given this material, this particular material. So how to create a material, how to create a particular material, I will just show you for one time. That one way is that you can, if you have properly extracted your library, then under this AEC materials you have the ready-made enlisted materials of Revit, which you can make the part of this particular browser window. From here you can just make it a part of browser window, duplicate it and use it. Or else another way out is that you can also use this particular asset browser, appearance library, and all this matte images, lots and lots of materials preloaded by Revit, which you can just make it a browser part of asset browser and use it. While say that just create new material, and with that default new material, and then just go to asset browser and just say that replace the current asset in the editor with this asset. This is called the editor. Fine. So that is how we create the material part, and that is how I have created the different types of materials using the existing materials of Revit. At the same time, couple of them are A lot of them are created from here only, from this particular existing library, and one which is not enlisted here has been created from this particular JPEG image, and a couple of them I have loaded this particular JPEG image. Fine, so that also I will show you that how to do that particular thing. So with this pathway, I'll just say that OK and 16, that's fine, OK and OK, and I'll just finish. Fine. Next is that this particular thing, yeah, fine. Okay. I will keep this particular file open for reference because apart from transferring the standards, even I need to check a couple of details. So now we will create another, let's say that floor architecture, and we have this mud, okay, and from here to here and from here to here, from which I will just exclude this so much part, a little bit of drafting, because this portion is going to be a different material. Split and TR and join this to this and join this to this. Fine. Let's just take this on the inside edge. Oh no, that's fine. Let's keep it here. Okay, fine. So with that we have created so much. Now time to create wall, compound wall. So wall, and I've already created that particular compound wall wherein you see that, yeah, main 9-inch compound wall. If I just go to edit type, then it follows the thickness of this 1 feet. It has been given the name, but let me just check. The thickness of this is 1 feet. Yeah, so the name should be edit type and rename. This should follow 1 feet. Okay, and that is this, the thickness is 1 feet, and this is the stone wall, which is neither following the material from the one that is provided by Autodesk here, neither from the asset browser, but I have just created a new material and then assigned this JPEG image to it, custom JPEG image to it. Okay, there are a lot of JPEG images. The seamless texture, you can just download it from Google and you can just use them as a mat for Revit. Okay, so I'll just apply an OK, and wall, finish face exterior, location line to finish face exterior, and unconnected height to, I'll just say that 8 feet. That's enough. And from that I'll just say that start drafting 1 and 2, and I'll come here and stop, and from here to here I will just draft 1, and then I will just say that wall, and since this is a curve, so I'll just say that pick, and yes, just flip it. I created 2 of them, so just delete 1 and just flip it. Okay, and I guess that it should be from here to here. Yeah, that's fine. 3D. Now not this 3D, actually this 3D. Okay, and we have this particular project started with modeling part. So VG, import categories, and I will turn it this particular AutoCAD plan to halftone in this 3D also. Clear, and R enter. So you see that the material follows, the material part follows. Now let's start creating the other elements of this particular ground floor, including the wall and the floor plates. So I'm just going to click wall, and from here this list I'm just going to select this particular main wall RCC 6-inch, which is given the material of concrete. Okay, which is going to be, this is the small pardi, and for this particular flower bed I'm just going to say that create that particular wall from ground floor and all the way to this point, and then I'll just say that pick lines for this curve and create that curve, and also I'm just going to create that same wall here, CS and ground level to not unconnected. I guess that I made a mistake over here. Yes, not unconnected 6 feet, but that would just be a small worthy of let's say that 2 feet. And same I'm just going to create over here, and the plinth is of 18 inches. So in this case I will just say that elevate it out only up to plinth level, and then I will just say that give it a top offset of 9 inch. Okay, so the unconnected height of that particular wall will be 2 feet 3 inches. So from here to here I will create that wall line, just a line. Yes, and we will need that wall over here also, same, and I will just say that yes. Okay, with that, now what I'm going to do, yes, also this particular garden wall, so CS flower bed wall. Okay, so unconnected height. Now this time I would like to just go to this particular project and just say that this unconnected goes to 4 feet 6 inches, and this is just 18 inches, I guess. Yeah, fine. So herein I will come to this particular 3 walls and just say that unconnected to 18 inches, that is height of the plinth. And here with this 3 steps leading to the plinth, this wall would be 4 feet 6 inches, that is 18 inches of this particular plinth, and then 3 foot from there. So I will select this particular wall and again say that CS, and just create that particular wall from here to here and here and here. Stop, because there is a column over here. Okay, fine. And with that, now we are going to create different floor plates for this particular project. So I will just go to floor and floor architecture, and all the floor plates have also been created. For example, you just see that plinth floor entrance foyer. So edit type and typical thickness of 6 inch, and just say that if you just open up this, then you see that this is an existing material of Revit which I have provided from this particular asset browser only, from this appearance library under any of this particular category, which I could not recall right now, but it is one of the existing material which I have replaced it into the editor, and that is how I have created this particular material entrance foyer. Okay, if you can want to adjust your tiling, then you can adjust this particular tiling from here. Okay, and just say that okay and okay and apply and okay, and with that I'm just going to say that draft that particular shape and snap it, and LI and TR, and join this to this. TR is the fillet of AutoCAD in Revit trim extend. Okay, and with that I will create that particular command with that particular entrance porch, and now the stairs leading to that particular entrance. So I will just go to this particular stair. Did we copy the stair type? No, we didn't. So I'll just go to the stair, and from there I'll just select this particular monolithic steps and just go to edit, and 3/4 inch of a nosing, and smooth I'll just say that 6 inch, that's fine. And for material part I will just say that stair material, yes, and that is just a paint, a color has been given to it. Okay, so I will just use that particular stair material, and nosing length I'll just turn it to 0 for now, and slanted also I'll just get rid of it, and apply and okay, and apply and okay. And with this, what is the width of this particular thing? 10 foot. So I will just say that run with 10 foot, and I would just say that I want to go from ground level to plinth level. The desired stair height is 3, so the desired number of riser is 3, and that's fine. I'll just, but the tread depth is 18 inches, so I'll just say that 18 inches, and with that run, and I'll just create it from here to here, and then adjust the sketch according to the AutoCAD drawing. Fine, and with this I'll just say that finish. Okay, and it has laid that railing also, but I'll just delete that particular railing. Delete, and top rail rectangular. Let's go to 3D and delete that particular railing from here. Yeah, that's fine. And you see that particular plinth floor entrance foyer we created in ground floor, we need to change this particular level to plinth level. Okay, so this is what something you need to take care about when you are drafting. So now let's draft the flower beds. So ground floor, and I'll just come to this particular floor architecture and grass. Grass, I have already created that. From ground floor, I'll give it a height offset of 1 feet and just say that pick lines and create this 1, 2, 3, 4. Join this to this, create that, and TR and join this to this. This should be a closed shape. At the same time, I'll just say that CS and a rectangle from which I will just get rid of this 1, 2, and 3. Split TR and join this to this and this to this, and this should be at the height of plinth level and 2 feet offset from plinth level. Because if you remember that from plinth level, the height of this particular wall is 3 feet. So if I just go to 3D now, then you can see that it's created, but this particular 3 walls will have unconnected 4 feet 6 inches. So from 3 feet, it will go up till from 18 inches, it will go have a parapet of 3 feet. Okay, that's fine. So now let's proceed further. What are the other floor plates? So floor and floor architecture, and let me just say that public areas. Yes, public areas, and I would just like to say that what is the material applied to that public areas. Yeah, this is also an existing material which I have loaded it from here only somewhere, but couldn't recall it right now. Masonry, I guess. Yes, from masonry only I have loaded that particular masonry, stone, marble. Okay, so apply and OK, and I'll just give boundary line and draw from this point to this point, and here in LI, and I will just draw this lines manually, TR, and join this to this and get rid of this line. Yeah, that's fine. Okay, and just say that finish. Did we create it? Oh, again I made a mistake. I was supposed to check this earlier. Plinth level and 0. Okay, so plinth level. On plinth level we are creating various different floor plates. Now again I'll just say that floor, and this time I won't make mistake. First is that I will just change this particular thing to plinth level with 0 and public areas 2, which pertains to, yes, so this is the custom JPEG image that has been applied to it, custom mat. So this is nothing but, this is the formal dining living, and this is the informal. You can also carry it to gazebo, which is not bounded by walls. Okay, so this is dining, kitchen, store, and this is the living room. So herein I will just say that from here to here. Yes, and I'll get rid of this and snap it, move from here to here, TR, and join this to this and join this to this. Okay, and also I guess that I need to take into consideration this part, TR, and join this to this. And here I have guessed that we have a little bit issue of snapping of lines. Okay, fine. And plinth level, that's fine. Okay, next is this particular deck. So floor architecture, and you have this pathway, balcony, deck, and terraced. This is the common floor plate which has been assigned this particular material. This, okay, so the custom material, and that has been applied to a lot of spaces in this particular project. For example, for this particular thing, it will follow from here to here, and this particular thing, TR, join this to this, pick lines, pick, and since it is on angle, so this error will pop up a lot of times even while drafting the walls and other things. So this particular thing will also have the same floor plate. So I will just go to rectangle and create from here to here, and both of that should be at plinth level, and just finish. And for this particular grass, I will just say that CS, and that should be on plinth level, and here there will be a, let me just check once whether that area does have, yeah, so here it is. Okay, so let's go to ground floor, and because I am drafting in ground floor level, so that's why every time I select the floor command, it's by default selects that ground floor. If I'm plinth level, it will select the plinth level, and from here in I will just select this and just give it a negative offset of 1 inch, assuming that that particular level is slightly down. And the same follows for here also, CS, rectangle, and okay. So all these are flower beds. Actually this, yeah, fine. Let's proceed further, creating other floor plates, wherein now we need to create this hardscape. So I will just say that floor FL, no, floor architecture, and let's say that hardscape, edit type, edit, and hardscape. This is again a custom mosaic flooring, which is the custom image that has been loaded by me. It has been given the sample size of 12 feet by 9 feet. Okay, and apply and okay. And I'll just say that pick lines, and with that, all of this should be picked for that particular flooring. And as I said, because of the angular lines, it will create this particular warning message a lot of times, but you don't need to worry, and just snap and create. Okay, fine. And this should be exactly at plinth level, and yeah, let's give it -1 inch and finish. Oh, this is left. Pick lines, yes, and just finish. Go to 3D, yes. So this is how we have created this particular different floor plates. Now what left is this particular other areas. So I will just go to this particular plinth level, and herein I would just say that floor plates and floor architecture and rectangle, and this is going to be the private areas. Where are the private areas? Yes, private areas, and that follows this material, Benchwood Java. This also is the existing material of Revit, which I have used from appearance library and from this particular category, wood. Where is it? Yeah, this particular category. You will find that particular material under this category. So okay, and apply and okay, and finish. But this I will say that 0 and finish. Now this particular thing is also the private area, bedroom, but I have created a different floor plate for that. Why? The reason being, if I just press R enter, then you see that this is the tiling of that particular floor plate, which is exactly horizontal. Fine, but this particular floor plate is at angle. So in that case, select this and CS and select create another. While going to the edit type, just duplicate it and create another, which I have already created, public areas 2. And also you need to go to that particular material and create a duplicate of that, a particular duplicate of that, wherein if I just go to this particular material, then you see that it has been given a rotation angle to match that particular angle. Okay, so I will just say that finish, and I will just go to this particular floor architecture, and private areas are also the two of the public areas too. Okay, private areas too, edit, type edit, and let me just confirm once, and yeah, fine. So that is given the rotation angle. Okay, and apply, and okay, and I will just create one from here to here, and since it is at angle, so as I said, it is going to pop up this error and that annoying beep sound. I know it's really annoying, but I can't help it. Okay, so this is bedroom to private areas too. Fine. Now next is that I need to create this CS, or actually I should have edit boundary, and this particular courtyard, this will be a open courtyard from top. If you just watch this, then you see that this is going to be let me just say, yeah, this particular part, this particular part, see this particular part, so it is going to have the same material, hardscape. Okay, open courtyard. So I'm just going to say that with this edited HL, I'm also going to incorporate this boundary to that particular floor plate, TR, and join this to this, and join this to this. Okay, and with that one finish, so one homogeneous floor plate, and R enter. Yeah, that's fine. Okay, so now what we need to create is this washroom floor plate, and herein I will just select this particular grass and CS, and at ground level with a height offset of 2 inch, I will create a floor plate over here. So let's assume that this is the washroom which is bounded by this particular, here there will be a curtain wall, both this, which will be having a terracotta screen, jali screen. See here, if I just come here, then you see that this is the terracotta jali screen, and HH, you might have seen this type of toilets, which is opening up into a open area, grass. Okay, so HR, and only this will be the solid wall. So I'll just go to this particular plinth level, and herein this is fine, ground level, and with the height offset of, let's say that 6 inch. Okay, fine. And now the washroom floor plate, wherein again I'll just say that floor architecture, and for washroom also, I guess that washroom floor plate, where is it? First floor washroom floor plate, washroom, yes, washroom also does have 2 because of this particular inclination. So washroom floor plate and rectangle, and I will just create this one which is exactly horizontal with the height offset 0, and then I would just say that create floor architecture, and this time I will just select this particular washroom 2, washroom floor plate 2, which is having the same material which has been assigned from here, asset library, and here this, here, yes, here this same material, but here after loading it into the editor, I have duplicated it, wherein this washroom floor plate is having a rotation angle. Okay, so that matches with the inclination of this particular wall, and with this I will just say that line, and from here to here, and I guess that pick lines. Again, it will pop up that ugly sound, and that's fine. TR, and join this to this, and join this to this, and plinth level and 0. Okay, and just finish it. Also, I need to create the same grass, so I will just say that select this and edit boundary, and here also you have the same design. So pick 1, 2, 3, and 4. TR, and join this to this, and with that we are completely done. I know one thing is left, actually 2 things are left, and here there is the wash, so I guess that this will also have this as a wash area and just finish. And now I'm just going to say that floor architecture and grass, not grass, but where are the parking quota? Plinth, Plinth quota grass. Yes, edit type, edit, and this particular custom material has been applied to that. Okay, which has been given the tiling of 6 foot cross 4 feet. You might have seen this type of quota stone with this grass incorporated intermediate a lot of at a lot of places. So I'm just going to say that pick lines, and again plinth level 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and yes, TR, and join this to this and have a close shape. This lines cannot be open, it should be a closed shape. Join this to this and join this to this. No, join this to this. Get rid of this line and drafting flaw. Okay, yeah, so here I made a mistake. Okay, and with that I'll just say that finish, don't attach. Okay, and last one, this particular water body, wherein I'm just going to say that water and floor architecture and water body base plate, which I'm going to create on ground level. And again pick lines and select this. Okay, and TR, and have a close shape and finish. And again go to floor architecture, but this time only water. Edit 2 inch of thickness and has been applied the material of water, existing material of Revit. Okay, and apply and okay, and just say that pick lines, and this will be created on plinth level with the negative offset of 2 inch, and just finish, don't attach. Just go to 3D, and with that all your floor plates pertaining to ground floor has been, plinth level has been completed. Fine. So now we are going to begin with the actual modeling part of this particular residential structure, where we are going to start creating the walls. So let's start with it, and I will just go to this particular plinth level, and all the walls here, since there is no structural consideration, there will be no ground beam, plinth beam, and all the walls will be elevated from this particular ground road level. So let me just go to that particular level, and VG and imported category, yes, that's half stone. Okay, and let me just click wall, and wall name main wall 9 inch, edit type and edit. And if I just go to the particular material, then it has just been applied the material of paint, wherein this color has been applied to that particular material. And I will start creating walls, ground road level up to, first we will elevate this wall only up to first floor level. So this is multipurpose room, and I'll just create the walls for that particular. Let me just start from this point. 1, 2, 3, 4, and this, because of this particular joint condition, so I will just say that wall joint and disallow joint. And this wall I will just take it till this point, and just again call this CS and elevate this wall from here to here, and the same. Okay, so I hope that's constructed. Yeah, fine. Okay, so let's create other walls. I will just say that wall, and the wall from here to here would just be a parapet wall. So ground road level and up till plinth level with the top offset of 3 foot, and from here to here, and also for this particular thing from here to here and here to here. Okay, let me just check. Yeah, that's perfect. Ground road level, and now this will be full walls. So I would just say that walls, and I would select this rectangular function up till first floor with the top offset of 0, and from here to here I will draft one cube. Okay, and with one shot that entire wall has been created. Okay, ground road level. Let's create other walls, wherein I would just say that here you see that there is a column, but that would actually be a wall because we don't have the structural consideration. So CS, and again this would be from ground road level to plinth level, top constraint to first floor. Yeah, that's fine. And create from here to here, and this wash. So herein I would create a wall from here to this particular point, press tab, and this particular wall, CC. Okay, now we have to create the internal wall as well. So just say that wall WA, and I have also that family or internal wall 4.5 inch. See, all the properties and parameters remain the same except for the thickness has been changed to 4.5. So this I will just create from here to here. Ground road level, press tab, and ground road level to first floor. That's fine. Okay, and herein this particular wall, this would be again the same that RCC wall, ground road level, and unconnected 4x6. That is from 18 inches. It will, or we can also say that up to plinth level and top offset of 9 inch. Let's just give the 9 inch. So I'll just say that CS, and this will be a purdy. So unconnected, plinth level, and top offset of 9 inch. Okay, so let's create that. Fine. And this living room wall, full wall, that will be, so CS, and from here to here and from here to here, and also this will go from, let's draft from here to here. Okay, and now this would be only up till plinth level with the top offset of 9 inch parapet walls. So press tab, all of this 1 to 2 and 3 and 4, and now we have to pick lines in order to match this particular shape. So what I'll do is just say that HL, I'll get rid of this floor plates for now, and until I can see the AutoCAD drawing, and just say select this wall and CS and pick, and let me check the constraint, ground level, plinth level, and top offset 9 inch. Perfect. And finish this exterior, and you have to snap until you have to, it should, let me just click and revert the direction, and click and revert the direction. Okay, so fine. Okay, complete. So also we can join this wall to here, but here there is a puncher with a beam over here. So what we will do, I'll just go to ground level, and for both this wall, I guess, yes, here also there will be a beam. So what I'm going to do is that I'm just going to select both of these walls, ground road level, and actually here there will be a wall at this point. So ground road level and plinth level. So I would just say that the base constraint should be plinth level, and the base offset should be 8 foot 6 inches, and the top constraint should be first floor. So that will change its unconnected height with the top offset of 0. It will change its unconnected height to 18 inches. That is the, and I will draft from here to here, and you cannot see it because it's constructed on the other level and go to here and ground road level, and I messed up for this particular thing. So MA, match property, select this and select this. Okay, perfect. And this too, this is first floor. Then what is wrong with this? A unconnected height, not ground floor and first level. Yes, and from plinth level, it should have base offset of 8 foot 6 inches. Yeah, that's fine. But just press tab and invert the direction. Okay, fine. So now what left for this particular floor plate? Yeah, this particular angled wall. So again, I will just say that CS and create from here to here one wall. I cannot find the snap points. So HR, and let me just say that wireframe, and I will just isolate HR, isolate this particular sim AutoCAD drawing, but that will hide rest of the other element. I'll again go to HR and unhide everything. And then I will just select this wall, ground road level up till first floor. That's fine. And let's try to create this angle wall, but it couldn't find the snap point here. Now, since it's an angle wall, so it will pop up this error, but just ignore it. Tab and until you find the snap points. And from here to this point, yes, okay. And I hope that this is perfectly created. No, see, there is a little bit of glitch. So I would just delete this particular wall and WA and this snap point to this particular face. But since it is still living this particular small error, so in this case, what I will do is that I would let's say that this AutoCAD drawing we need to, so this AutoCAD drawing and one wall and IC, that is isolate category. You can do it from here also, isolate category, and then I would just say that wall, and then I will say that pick lines, and with the same constraints I will just try to yes, yes, and now it will be perfect. Okay, see, so now it is perfect, no issues. And then I will again say that wall, but this time the top constraint should be, because this is going to be just a small parapet, so wall and up to the plinth level with a top offset of 9 inch. Okay, and I will again say that pick, so 1 and 2. Yes, that ugly sound I hate it, but you can't help it because those are angular walls. So this internal walls CS, and from ground road level to this time first floor. Yeah, that's fine. And pick and snap to this AutoCAD drawings. Okay, and here this would only be up till plinth level with a top offset of 9 inch. Yes, okay. And here there will be a terracotta screen jali, which will be here also. Okay, this particular one wall. So wall CS and ground road level to first floor for now. Okay, and with that we are completely done creating all the walls for that particular designated floor plate. This is left, so let me just check which wall is that. Yeah, it is a full wall, so angled full wall. So I need to create that. So CS and again ground road level to first floor, and with that I'll just say that pick. Okay, and let's go to 3D. Fine. So you see that we have quickly created the wall, except for this particular. There will be a beam over here, which will join this entire clear. And this, I guess that there is a join connection, join problem. I guess this will stop at this point. Yes. Okay. Perfect. Again, let me just check. So this wall should, I would just say that wall joint. And why is this wall taking over? Yes. So wall joints and select this junction, disallow joint, and yes, disallow. Okay. And this should join with this. But since we have said that disallow, we again need to join and take this wall all the way out and then join. No, but not working. We need to say that allow join for this also. Then, yeah, fine, perfect. So these are the basics and fundamentals of wall joints. Again, you see that this particular wall, we need to say that here too, I would just say that click and disallow join, and then select this and select this wall, and this should come to here, and now it is perfect. Yeah, fine. Okay, clear. So here we need to draw beams 1 and 2. So that would be, let's draw it in the ceiling plan of Plinth level. Ceiling plan of Plinth level. Yes, so we can see it. Okay, so I will just select this particular wall, and the constraint will be same, base constraint Plinth level, but it would be given a base offset of 8 foot and 6 inches. And the top constraint would be first floor, which would make its unconnected height 18 inches, that is the beam depth. And from here to here, I will draw one, but the internal wall not, main incline wall. And from here to here, I will draw one wall. And from here to here, I will draw one wall. So that would, but this again should be in alignment. This one. Oh, see, here also it has. So I would just like to say that here too, I will just say that disallow join, not ground load level here, and just say that disallow. The join conditions you need to properly work out. And I will just say that split. And I'll split this wall, snap it till this point. This wall I will snap here, and this wall I will snap till here. Okay, so this will be 2 feet. Yeah, fine, this wall, wherein there will be a column. So now this beam will snap perfectly to its location where it is supposed to be. And now if I just go to 3D, fine, perfect. Okay. Except for if I just go here, then this is getting inserted inside. Yeah, fine. And even I can join this to this and join this to this. Okay. Fine. So we are completely done with the creating the walls of this particular designated level. Now, this particular wall, this will be a terracotta jali screen. Okay. This will be a terracotta jali screen, which I have already transferred from that particular existing project, existingly built project. Okay, this particular screen. So I will just go to, let's say that HR, and I will just go to wall, and here I will just select this terracotta jali screen. It is just a curtain wall. It is just a curtain wall, which is, I guess that reset constraint. Yes, and wall and terracotta jali screen. Yes, and ground road level to unconnected. Fine, that's okay. But it is just a curtain wall, which is referencing this curtain panel terracotta tile. Okay, terracotta tile. So what is that? So here, if I just drop down, then under curtain panel, you will find this nested and embedded families. If I just go to edit type of that, then what is it? This is nothing. But if I just go to reference level, then in generic model template file, in curtain panels template file, this is just created a piece of extrusion. So this is the parametric stuff. So if you want to learn all this particular thing, then you need to enroll for this particular course. So if I just go to exterior elevation, then you see that I have given two parameters. That is a width cross height, which is 6 cross 6, and it is nothing but just a family, edit family, which is again now a generic model, which is nothing but just a simple piece of extrusion. Okay, this is an extrusion. See, HL, HL, and this is an extrusion, and all these elements are also just a piece of extrusion. So this is created a generic model, which has been nested and embedded in this particular template file, curtain panel, where it has been given parameters both in plan and in elevation. And then that particular thing is being referenced here in the project environment in the curtain panel. Okay, curtain wall panel. So I would just say that wall and terracotta jali screen from ground level to unconnected right now. Don't worry about it. We can just take it right now up to first floor. But it is 6 cross 6, so it should be a round figure. So from here, I will just measure this. How much is this? So 3 feet 6 inches. So you see that automatically it will occupy that particular space. So from here to here, I will just draw one, and from here to here, I will draw one. Okay. And you see that 1, 2, 3, 4, 5, 6, and 7 modules of that. With that, I will just edit this boundary and take this all the way till this point. Okay, and this to here and just finish. And now if I just go to 3D, then you see your terracotta jali screen is being referenced perfectly with this module of 6 cross 6 repeating across this entire length. Okay, and we will take it above also. See, we can take it above also, and that will multiply. But right now, let's go as per the needed functions. Okay, so here this screen will persist over here also. So ground road level, and just say that select CS. Okay, and I would just say that from here to this point, and press tab until you find the snap point. Yeah, and that will pop up an error. That's fine. And again, you need to select this particular edit boundary and just snap it. Okay, and just say that finish. Okay, so let's go to 3D. Yeah, fine. So here also it is created. Okay, now there is a one special wall which is coming over here. It is nothing but just the I will just show you that how to create this particular wall. But before that, let's create the railing. This is the curtain wall. This is the curtain wall. It is nothing but, again, if I just go to this particular ground road level, now we don't need to elevate the walls from this particular one wall will be elevated. So I will just go to wall, and let's say that where is that particular wall? Special wall, and edit type, edit, and this material has been applied to it, brick cladding. Okay, and this is also again an existing material of Revit which I have applied from here only, appearance library, and you even if you just type brick over here, then you will find that over here, which you can make a part of this editor and just reference it by duplicating it. Okay, so herein I would just say that HL, and I would just say that line, and from center line, no, sorry, location line should be finished space exterior, and from uh, ground road level to first floor. Fine, that's okay. So from here to here, I will just find a snap point and create that particular wall. Let's go to 3D. Yeah, fine. So that wall has been created. Now, how have I created this particular wall, this particular thing? So that is very simple. So I would just draw a section which is exactly parallel to that particular wall. Okay, and with that, I will go to that particular section, and here I will turn this to realistic. Okay, and then I will just select this particular wall, and let me first check the constraint of this. Plinth level to first floor only. Yeah, that's fine. So section 1, and herein I will just say that edit profile. Okay, and with this now you need to create this particular different niches and this profile. But instead, for creating that, if you want to follow this particular brick pattern, then what you need to do, you need to say the ground road level and PK, pick this particular plane, pick it and go to section 1. With this, now you will have an ability to draw LI, and let's say that you want the profile, something like, you should follow the brick pattern. So from here to here and here, and this particular error will, this ugly sound will pop up a lot of times, but you just have to ignore it. And from here to here, and likewise, I will just try to follow this LI, and because of the angled line, it is creating that particular, and just stay tuned. I'm just drafting randomly. Okay, and fine. Okay, so I have drawn that particular profile on that particular work plane. See, okay, so this, I guess that I need to adjust. Yes, with this, now I will just select this particular thing and say that edit profile. So I hope that you can see this particular lines. So what you need to do, you need to delete this particular line and say that pick lines, or let's say that lines LI, and just draw the lines following that particular profile. So just stay tuned, and we are almost done. Okay, and TR and join this to this, and just adjust this a bit. Okay, TR and join this to this. Okay, so we are TR and join this to this, and it should be a closed shape. Okay, so we likewise we have created this particular wall, this type of wall. Fine. And with this, now if I just go to this particular section 1, then I will just select this particular wall HH until I see this line. Select this line, and I see that I select category, select all of them, and just delete it. HR. Okay. So that is how I created this particular wall. And now we need to create the railing for this particular wall, this particular railing. Okay. And also this is curtain wall, glass panel. Okay. So I would just go to this particular ground road level and say that W wall, WA, and under curtain wall, you already have this curtain wall corner dark glass. If I just go to edit type, then it is nothing but it is referencing this curtain panel, glass wall 2. Glass wall 2. So what is that? That is nothing but that is a wall only, glass wall 2, which has been given this 1 inch thickness, and it has been referenced this material of dark glass. Okay, so that has been referenced within this curtain wall in order to create that particular curtain wall corner dark glass. And for that, I'll just say that plinth level and plinth level base offset of 9 inch and unconnected, I will just give it a height of 3 feet. Okay, so herein I will just create that particular wall from here to here and here to here, and you see this flush connection that you get, okay, on corners for even that curtain wall. So corner curtain wall. Okay, and let's go to 3D and check. Yes, fine, perfect. It has been created perfectly, no issues. Now I will just go to this particular ground road level, and now we don't need the ground road level, but we need to come to plinth level. Okay, And for Plinth level, I will just say that wall. And here again this particular curtain wall, which has been bridge curtain wall, because here we are going to reference that curtain wall onto the bridge for on the first floor. But here also at couple of places that have been referenced. And here again there is a problem of joint condition. So this I get that should snap to this. So let me just check what is the issue. Yeah. So this wall is coming all the way till this part. So what we need to do, we need to select this and snap it here. This should stop here. Yeah. And with this, now this can come till here. Okay, perfect. Fine. So I will just go to this particular plinth level and wall, WA, bridge curtain wall, plinth level 9 inch and unconnected 3 inch. So I will just snap here. But important to be noticed is that if I just go to edit, then your curtain panel is empty. And this vertical grid is saying that fixed distance 6 inch, wherein this vertical mullions, there are no horizontal mullions, but this vertical mullions 15 cross 2.5 has been referenced. Okay. If you want to reference the horizontal mullions, that is also possible. But let me just first show you that what does it create with this. Okay. So this is the railing that it has created. Now you can manipulate this in a lot of ways. For example, if I just say that edit type and here I would say that I want this copy for this horizontal mullion also and horizontal grid, I would just say that fix distance to 6 inch and just say that apply and OK. Then you see it will create this such type of screen, jolly screen. Okay. So railing, sorry, not jolly screen. Oh. But I would just say that undo. And you can also redo. And with this, if you want, while going to the instance parameter of this particular, press tab and select this curtain wall. And here in the vertical grids, I can just say that 45 and 45. You can create such type of railing also. Okay, I guess that this looks good. Fine. So let this be the railing. Fine. And I would just go to plinth level and I would just say that select this curtain wall, select this and CS, and I would draw that from here to here, copy, and I would pick lines here, and again I would pick lines and here with that same constraints. That is plinth level 9 inch and fine. Let's see that what it has created. Oh, perfect. Okay, now what you just need to do, select all these 3 curtain walls, 1 and 2 and 3, and go to the instance parameters, wherein this, I guess that IC, isolate category, IC, because it is angled, so how to select it? Let me just, yes, and it's not allowing to, yeah, give that angle parameter. Where is it? Not allowing here. I guess that, yeah, see, for this particular straight, it is providing that angle parameter. So I guess that you are clear with this particular concept. So for this particular thing, let me just say that since it is angled, so oh, come on. SA, that will select all the curtain walls of that particular category. And because of this is angled, so that's why it is creating a problem. So I will just edit type and duplicate this to, wherein I will just get rid of this particular horizontal ones. Okay, so none, And the horizontal mullions, I will say that none. And apply and OK. Delete grid line. Yeah. And this too, I will just turn to that particular two. OK. Delete grid line. And herein, I will just select this particular one and turn that delete grid line. Okay. And this will now be one homogeneous HR, one uniform. Okay. One uniform railing type. Here, let it be. So now, also let's create the same curtain wall over here also, which would act as the railing. So plinth level, and just select this and say that CS plinth level 9 inch and unconnected 3 foot. That's fine. And create it from here to here and just finish and 3D and yeah. Okay. Now let's create punchers within this particular some of the spaces wherein you see that this is informal living, which would act as a gazebo or informal space, which had this particular no walls and punchers over here, and at the same time here too. Okay, so the 3 punchers we have to create within that wall. So I'll just go to plinth level over here and delete this particular section. And herein, I would just say that HL, and why is this wireframe, and hide that particular AutoCAD plan, but we cannot select it from here. So I would just say that underlay, change to none. Okay, yeah, fine, that's okay. What is this line? HH. Oh, this is the floor plate. Yeah, so the puncture will be till this point. Okay, so HR, and I would just say that architecture, and under here you have this option to create the puncture wall opening, cuts a rectangular opening into the straight or curved wall. So I will just select this and place it from here to here. And then we can just adjust that constraint according to the AutoCAD plan. And this, I would say that base constraint to be plinth level and top constraint to be first floor, but with the base offset to 0 and top offset to beam depth. Okay, and the same would be here. So I would just say that select this and select this rectangular cut CS and draft it on here also. Place it one over here and one, sorry, undo, and place it one over here. Okay, and then the constraint would follow the same. That is, both of this 1 and 2 would have start from plinth level with base offset of 0, but the top offset of minus 18 inches. Okay, and top constraint is first floor. Now we need to adjust this cuts. Okay, and this will be, I need to draw reference planes in order to snap and snap this to this. Yes, and unjoin elements, that's fine. No, but that will create a problem. So let it be this much silver, it's fine. And here, this would be up till this much. Okay, and likewise, the same way, this up till here and this up till here. Okay, now let's check in 3D. Okay, fine. So the puncher has been created. Okay, fine. This could be a little bit longer. So I can have this puncher all the way till this point. So in that case, this walls, I guess this AutoCAD plan is till this point. Okay, fine. Let's continue. We will adjust it later. Now we need to lay the staircase, which will lead to the first floor because we need to create the first floor. So plinth and wireframe. But on plinth level, we don't have the AutoCAD plan. We have the AutoCAD plan on ground level. So from here, I will just select this and go snap it to plinth level. Okay. So herein, I just go to VG and imported categories and turn this to halftone, apply and OK. Okay, so there are 18 risers which are having this particular shape. So modify and measure this. This is 1 foot and the stair width is, it should be 4 feet, I guess. Why is this ugly fraction showing? There might be some glitch with the AutoCAD plan. Okay, we will consider it 4 feet and then draft it. So architecture and stair, and again that monolithic stair, but this time the actual run width would be 4 feet. Okay, and I want from plinth level to first floor with the desired number of risers to be 18. Fine, and the stair width to be 1 feet. That's fine, and I will just draft it from here to this point. Okay, so that has been created. Move it. We need to adjust the shape. So in order to adjust the shape, what we need to do is that we need to convert it to sketch based component. Okay, and edit sketch. Fine. So this particular shape is different. So herein I will just select this particular boundary line and delete. No, not delete. I would just say that, sorry, TR, and join this to this. Okay, and this riser will snap till this point. Okay, and pick lines, join this to this, and join this to this. Sorry. I guess that risers. Okay, one risers created, 17 remaining. What is the issue? I suppose that this entire would be the boundary line. Yeah, and join this to this and boundary, and click from here to here and join this to the boundary and line and join this to this. Yeah, so 18 risers created, 0 remaining, and this is the path. Okay, clear? Edit type and smooth 6-inch stair material. That's perfect, and just finish. Fine. So that particular staircase has been created. So just click undo and go to railing part and just get rid of this particular railing for now. None. Okay, and finish. Okay. So that particular staircase has been created of that particular shape. Fine. Now there is a sit out over here, sit out space, which we need to create it with a slightly different method, wherein I would just say that reference plane and draw this plane over here and just create a section, flip it. Okay, and just say that PK, PK, and pick this particular PK and pick this, why is that not allowing wireframe, PK, and pick this particular reference plane. If you are in visual hidden style, let's say that A trail, this is the visual hidden style. So you're not able to create reference planes. Okay, reference planes are grounded. Okay, so you need to change it to wireframe from here, wherein I have added the shortcut WF. Wireframe, PK, pick this reference plane and go to section 1. With that, you can see this particular staircase. I just say that select HC height category. Okay. And this is the floor plate, which is putting up at plinth level. So here I need to create an extrusion, which would be actually, this would be of the shape. Let me just check over here. Let me just go to this existing and I just HR and just select this particular. Yeah, so finish and okay, and this is that particular piece which we need to create, which would follow this inclination. Yes, let's just try to create the set architecture and component and model in place, and would be a stair component. Stairs and OK, which would be having an extrusion of let's say that 3 foot. A 3 foot would be too much. Sorry, let's give it a 14 inch, and then create this particular thing, which would be having stair material, stair, the underneath of that particular staircase we are creating. So just finish and go to plinth level where it has been extruded. It's actually in the wrong direction. Just snap it here and let's see. Yeah. Okay, fine. That's created. Okay. So that is how we have created that particular part. And now we need to create the floor plates on the level above. So what we are going to do, we are just going to go to first floor, and we cannot see anything. I need to say that change this underlay to plinth level, and with that we will be able to see the profile of the elements that have been created on the floor below. So now we have to create the floor plates for this particular level. So herein I would just say that floor and architecture, and I would be having this public areas too. So we are going to snap public areas for this particular entrance. Actually, let's snap this particular, so it will be easy. So I'll just say that delete it, and this particular AutoCAD drawing, I'll go to plinth level, and this particular AutoCAD drawing, I will just take it up to first floor. And while going to first floor, I need to snap it. So VG, imported categories, first turn it to halftone, apply and OK. And now if you have to find a common point, LI, and this is the point. Okay, so modify and align this point to this dot. Okay, so that is how we have snapped the AutoCAD drawing on that particular. Fine. So now let's say that since the AutoCAD drawing is snapped, so in order to avoid confusion, say that I don't want to see that what's happening below. Okay. So with that, now we have, this is the floor plan AutoCAD drawing of that particular first floor. So let's start creating the different floor plates. So again, I'll just go to architecture, floor architecture, and this would be public areas, and just a rectangle from here to here, and yes, TR, and join this to this, and join this to this, and just finish. Don't attach. Okay, and this would be bedroom. So floor architecture and private areas. I will just draft this 1, 2, and 3, and rest we can no, but here also we need to say that pick lines 1, 2, 3, 4, 5, and 6. TR, join this to this, and that is how we have created. Okay, don't attach. Floor and washroom floor plate. Washroom floor plate. Just create a rectangle from here to here. Just finish. Don't attach. And this would be floor and floor architecture, pathway, balcony, deck, terrace. Fine. And just pick 1, 2, 3, 4, 5, and because of the angle lines, and I would just say that line 1, 2, 3, 4, and TR, and join this to this. Okay, and just finish. Don't attach. R enter. Okay, so that is how we are creating different floor plates on different levels. On first floor, sorry, not different levels. And here in now this particular floor. So floor architecture, but this time private areas too, which is having that particular material, the same material, but at the rotation angle which would match the inclination of the wall. Okay, 45 degree. Done and okay, okay, apply and okay. And HL, in order to see the profile, I would just say that line and 1, 2, 2, and just create it. Okay, and just finish. Don't attach. The same way the floor architecture and washroom floor plate. 2 pick lines. 1, 2, 3, and 4. This should okay, and TR, and join this to this, and join this to this, and finish, and don't attach. Okay, and this particular thing, I get that balcony also has that same. So I would just say that edit boundary and pick 1, 2, 3, 4, 5, and 6. And this would 1, 2, 3, 4, and join this to this, and join this to this, and just finish. Don't attach. Okay, and here there will be a flower bed. So flower architecture, floor architecture, and grass. Where is the grass? Yes, here it is. And just a rectangle. Okay, and finish. Don't attach. Okay, now from this particular bridge, you have an access to this particular bedroom. But if you just watch this point, then this is the overlooking. This is the double height. This is the double height, and you have a staircase over here taking you to this particular this level, semi-covered patio. Okay, this is a semi-covered patio, wherein this particular staircase is leading you at that particular intermediate level. So what I need to do, I need to say that stairs and this particular cast place monolithic set from first floor to, I would just say that none. And desired server, I would just say that 3 foot. And desired number of risers to be 6. Let's just draft it. And I will draft it from here to here. Okay. But what I'll do is that I will just say that convert this to sketch base and edit this particular sketch. And I would take this part here. I would take this particular part here, join this to this, and this to this as well. And herein I will just extend the stair path, and I would draw one more riser over here. Okay, so 7 of them created. Okay, I would have mentioned 7 in that particular design number of staircase. That's fine, you know. Okay, let's move further and just finish. So 6 plus 1, because in the stair type we mentioned that we need 6 risers, but that's okay. Just finish it and just flip this particular section and create. And let's see that what is the height that is going up to 3 feet. Yeah, that's perfect, fine. Okay, so if I just take it to particular plinth level, and if we take this particular section over here, then we see that from this particular staircase you are going to this particular first floor HR, and that's first floor, and that from first floor you are going to our intermediate level to that semi-covered patio. Okay, so this is that particular semi-covered patio which you are leading to from this particular staircase. So we need to create the floor plate of that. So I would just say that floor architecture, floor architecture, and that would be same pathway, balcony, deck, and terrace. So I would create one rectangle from here to here, and I would just say that line and get rid of this particular staircase. TR, join this to this, join this to this. And also we need a headroom over here when the person is climbing this particular staircase. So I would like to say that deduct 3 feet from that and join this to this. Okay, and herein we will have an extended balcony of, let's say that 3 foot and 3 foot. I'll just say that 2 feet 6 inches is enough, or let's go for 2 feet and LI and just join this to this and this and TR and join this to this and join this to this. Okay, now let me measure that what is the distance. 17 feet is too much. We will keep it only this much as per the floor plan for now, and then we'll adjust it later. Okay, so let's say that this would be at level first floor, but the height of step from the roof should be at 3 feet in order to reach the top of this particular staircase. So let's see it in section that where has that floor plate created. Yeah, fine, perfect. Modify and measure, and yeah, fine. So perfect. So if I go to 3D, then you see that you have this. While coming on this pathway, you have an intermediate staircase which is leading up to this particular patio. Okay, semi-covered patio. Clear? So now we are done with creating the floor plate for this particular designated first floor. Now we need to create the walls of this particular floor plate. Okay, fine. So this we can, I guess that this follows some negative offset over 0. That might be the case with all the floor plates that we laid. I just need to somehow by mistake, I might have clicked that particular 0.2 minus 2-inch offset I gave, but fine. And this also should be 0. And likewise, this also should be 0. Yes, fine. Okay, so now we have to proceed further, creating the walls of this particular level. So let's just get rid of this join and join this to this. Get rid of the, yeah, fine. And herein now we are going to create the walls of this level. So I will just go to first floor and just say that this would be this particular wall. If you just watch this particular thing, then this wall is a different wall. Just for the sake of elevation treatment, this 1, 2, and 3, this particular walls has been different walls, which has been applied just a different material. Okay, so that would be wall. And for in that case, I guess that we need to get rid of this particular beams, because that will anyway be created once we lay that particular according to the top floor plan. So this beam and this beam I think that I should get rid of. Okay, and now I'll just go to first floor and wall and main wall 9-inch special wall. Yes, brick cladding too. Okay, and with this I will just say that the base offset to be minus 18 inches, which would act as a beam for the level below, and top constraint should be, right now I would just snap it to slap top, that we will adjust it later once we lay the roof. So from this point I will just say that finish face exterior, and from here to here I will draw that particular wall from here to here and from here to this point. Okay, and let's go to 3D. Yeah, fine. That particular wall has been created, and this is now acting as a beam. So this particular wall, I would just say that attach this will be, yes, this will be, I'll just say that attached to this. Yeah, fine. Okay. Okay. So now other walls. So also herein I just need to get rid of this particular roof wall. from that particular floor plate. Yes. And just go to first floor. Let me just see the floor plan. And here we have a wall. Yes, we have this particular entire wall, but that will be manipulated in a slightly different way. This wall, and this wall. Okay, this three wall will be manipulated slightly different, but let's right now just place it the way it is supposed to be. At the edit boundary and snap this inside. Okay, and let's say that wall WA, and herein this would be now the main wall, which would say that now get rid of this beam and up till laptop. Yeah, fine. For now, just place it. And from here to this point, yes. Okay, and we will have that from here to here and from here to this point. And here we will have just a small sliver of 9-inch, wherein we will have a beam bottom minus 18 inches and up to unconnected only up till 9-inch. And just unconnected 2 feet 3 inches. 18 inches plus 9 inches, that is 2 feet 3 inches. So then we'll be able to visualize that. Highlighted walls overlap. Yeah, I will just snap it till this point and this to here. Okay, so let's see. Yeah, fine. Okay, clear. But this wall would be the simple walls, that is main wall, regular wall with that wall paint. Okay, now we will just manipulate this particular part later. First, let's complete with the other geometries which are simple. So let's go to first floor, and this walls, I guess that wall and 9-inch, and this time I just say that 0 and up till slab top. Okay, and I will just create one, and this from here to here and here to here, and likewise, and complete the shape. Press tab until you find the snap point. Yes, and here. Okay, and WA and that internal wall, this internal wall with the same constraint from here to here. Okay, and let's complete this angled wall also. So wall with that internal wall, just snap it from this point to press tab until you find the snap points. Or actually in this case, we can take the walls above, because these walls are going to follow the same profile. So 1, 2, and let me just check. Yeah, fine. So 3 and 4 and 5, and all of these walls will go till slab top. Fine, and this jali also will go up till slab top. Okay, clear? Yes, fine. Okay. So far everything is perfect, no issues. And now we need to proceed further. Wherein first I will like to say that this wall from ground floor to, let's say that's slab top, and this both also I would like to say that slab top. Okay, and here in this particular wall, I will just say that copy to clipboard, paste, align to selected level, and drop it from ground floor to first floor. So that will copy that particular element. Okay, so next is that we need to create this particular this walls. And did I take? Yeah, fine. So this particular, I took it to that particular level, first floor, and this particular wall. So I will just say that walls, and that would be main wall 9 inch, but first floor minus 18 inches. That would be for beam, and top constraint would be set unconnected, adding 9 inch to that. So that would make it 2 feet 3 inches. Okay, and I would create that one. Sorry, undo 1, 2, snap point 2 and 3 and 4, and let's draw it till this point and then connect. Okay, and likewise CS, and that would be the same for 1, 2, 3 and 4. Let's check. Okay, yeah, fine. So let's add railing to that particular part. I'll just go to first floor, and herein I would just say that wall, and that would be curtain wall corner dark glass. Okay, but this time the constraint would be first floor and 9 inch and unconnected 3 foot. Okay, so just draft it from here to this point, and from here to here, and from here to here, and that would create the railing, glass railing, which would in this case be from this edge to this edge. Okay, fine. So that's created. And also I would like to complete this particular part, wherein I would just say that go to first floor, and I would create walls and regular walls, which would be wall main inch, main wall 9 inch, and this time it would be minus 18 inches, and unconnected would be 8 foot. And draft a wall from this. Let me just check once so that I don't end up making any mistake. If I go to the first floor plan of this, then that particular wall, yeah, that's it being created on this outer edge. So that's fine. So I will come to first floor of this, and with that wall and with that same constraint, I will just create a wall, but the location line should be finish face exterior from here to here, and from here to press tab this point, and press tab this point, and also from here to here, this point. Okay, and this will join, but that's okay. Let's go to 3D. Okay, yeah, fine. So this I need to disconnect. So I would just say that and disallow join. And yes, and this would only be till this much, so much part, and the machine will adjust that as per the site condition. But right now, let's just say that join and this to this. Okay. Now I would like to say that these are the complete walls that have been created. Okay. But I would like to add curtain walls to this particular walls that have been created, wherein wall and bridge curtain wall, and the constraint this time would be first floor 9 inch and unconnected minus, or let's say that not 8 foot, but let's keep it something like 6 foot 6 inches, and draw from here to here. That would automatically embed within that wall from here to here, and Yes, because of the angle from here to here. Again, we pop up that error. CS and create it from here to here. But I suppose that let's just check it in 3D. No, this was not supposed to be the curtain wall. It was supposed to be simple. And delete grid lines. Okay. Let's just delete it and draft it once again. First floor and delete this as well. And wall and this simple one. Okay. Which is having only the vertical segments. Yeah, fine. But it's automatically embed check on. Yeah, fine. And from here to this part, and from here to this part. Okay, and let's just check in 3D. Yeah, perfect. But why didn't this has been perfectly snapped, but this is not creating the puncture? Is this unconnected height 8 feet? Yeah, that's fine, 8 feet. Why is this? Let me just lower down a bit. Then too, it is not creating the puncture in that particular wall, even though automatically embed is checked on. Let me just delete and try once more because it is angled. So might be highlighted walls overlap. Yeah, so see, that is a problem. How I did for this particular thing. If I just delete this, yeah, see, this is the complete wall. So it has incorporated here, but this automatically embed checked on. But there it is creating a problem due to some reason. So I will just delete this. Again, let's try once more. And hopefully it should create that highlighted walls overlap. Let me just do one thing, move this particular wall outside and then say that wall and create that particular curtain wall. That is also not working. So I guess that I need to delete this particular wall, both the walls, and just say that go to first floor and select this, press tab and select this wall also. And sometimes you have to try an alternate method to make it work. Yeah, fine. And this, I will just join it to this particular part. And you see that it's not perfectly joining, but I would just say that allow join. Yeah, fine, and done. Okay. So sometimes you have to find an alternate method, an alternate way to get things done in Revit. And just extend this a bit till here. Okay, fine, clear. So, and just take it a bit. Okay. Now we need to lay the roof for all this particular elevated walls. Fine. We need to lay the roof on this. I would just say that go to select this particular floor plan and just lay it to slab top. And I would just find a common point wherein if I just go to slab top, we can, except for the AutoCAD plan, we cannot visualize anything because nothing is there at that particular designated floor plan. But what I will do is that just turn on the underlay. Underlay to first floor. Yes, fine. And I could find this common point of this. No, but that is also not. So Li, and this would be the common face. Okay. So from there, I will just say that align, click this and press tab until you find this dot and snap it. So that is how I have laid the AutoCAD drawing on that particular designated floor plan. And we have to start with this, placing this particular different roofs, wherein first we will create this particular roof, which is 12-degree slope, and edit footprints. Here is the slope defined. Okay. So I'm just going to say that go to slab top in this particular floor plan, and here I would just create that particular roof, which is coming till this point. Where is it coming in plan? I forgot to check how much it is extruded. If I just go to the second floor plan of this, then I would be able to find that it has been extruded approximately till this part. Okay, and just finish. Don't attach, and let me keep this open for reference and slab top. And herein, I would just say that architecture and roof by footprints. And I will just draw this complete rectangle from this part, snap it here on this line, move it to this line. Okay, TR. And here too, I will just extend till here. Again, it's, yeah, fine. TR and join this to this and join this to this. Okay, and here, roughly, I will just take it 4 feet and draw this line and create that particular roof. Okay, and here the line would be this. Let's, again, I said that I need to check it for reference. So edit footprints and wireframe. Oh, on wireframe, nothing is visible. CC. Okay. Yes. So let me just finish this particular thing. Don't attach, and let me just hide in view by element. Hide in view by category so that I can properly, yeah. So this is the proper face wherein it's supposed to. Now I can visualize the footprint. Yeah. So this is perfect, and this is how much? 3 foot and 3 foot of projection. Yeah, fine. So I will come here and just say that TR and this line is flushed as per the design, and from here it is move and 3 foot. Okay, and from here also it would be move 3 foot. Yes, join this to this, and this particular face is flushed. So is it flushed? Yeah. Here we don't have any projection. Okay. Yeah. So I'll just go to this particular laptop, and for all of this lines, I'll just say that define slope unchecked, and we'll have the slope here of, I'll say that define slope check, and UN, I will just convert the slope to degrees. Okay, and fine. And this would be, the slope would be how much? Edit footprints and 12 degrees, and offset from roof base is minus 2 feet. So offset, yeah, this much is the puncher. Okay, so this much is the puncher. Okay, get rid of defined slope and check for all this. And minus roof offset from base is minus 2 feet, and the slope degree was 12. Okay, and with that, I would just say that finish and just check. Oh, perfect. So this has been created. The thickness of it, I'll just change it to 6 inches. Apply and okay. Yes. So with this, now what we need to do, we need to say that all the walls, press tab, select this all the walls, and this walls will not join, but I would just like to, okay, let's do that particular thing in floor plan, first floor, and press tab, select all this wall, deselect this wall, and also this wall. Actually, let me just say that I select category. Okay. And with that, I will select all this particular walls. This walls too. Okay. And all this walls with that selected, I will just go to 3D and say that attach top base and attach. Delete that. Oh, sorry. The curtain panel also got selected by mistake. So I would just again go to second floor. Sorry, not this particular thing. This first floor, and say that I select category, select all the walls, deselect this wall, select this wall as well, and from this, let me just manually select the chain of walls that has been created, and this, yeah, fine. So that's enough. So that much walls, I will just go to 3D, and with that selected, I would just say that attach top base and attach. So yes, so perfect. Okay, with this, you can also now lower down this a bit, wherein this is slab top, I would just give it a negative offset of 2 feet. Yes, okay, clear? Fine, so that is how we have created this particular sloping roof. Okay, we need to create the roof on the top of this, but that would be at the first floor. So HR, and I need the AutoCAD plan. Let's create it at second floor only, as laptop only, but we will just move it to that designated location. So this time I would just say that floor and roof by footprints. And this should be, the base level should not be slab top, but it should be first floor. And I will just say that lines and draw the lines. 1, 2, and 3. Press tab 4. Yes, and this was press tab and select this point and okay. And from this point to this point and TR. And since this will be a flat roof, this would be a flat roof covering that particular pathway. I will just select this and define slope uncheck. And 6 inch, that's fine, default thickness, and I will just finish. Don't attach. And let's go to 3D. We created at first floor. Slab top and give it a base offset of minus 2 feet. Yes. Okay. So it was supposed to be created here only. It doesn't matter even if we snap it to slab top, but I am just worried about this particular roof. So first let's check here. Second floor and minus 1/16 of an inch. Okay, so I would just come here, select this particular walls, 1, 2, 3, and this wall. And with this 4 walls selected, I will just say that attach top base and attach. Okay, yeah, fine, perfect, no issues. Yeah, okay. With this minus 2 feet of offset, we will change it later. Right now, if you want, you can just get rid of this and just create it at that particular level if you want. Then we will adjust it later once we place this roof, depending upon how is this roof created. Sorry, this was not supposed to be created at first floor. It was supposed to be created at slab top only. Sorry, I just got confused with this laying of this particular sloping roof. Okay, fine. So let's create the other roof. So I will just go to this particular slab top, and herein first we will construct this particular roof. So I will just say that select this particular roof and CS, and just say that pick lines. So again, 1, 2, 3, and actually this roof will cover this balcony also. So the profile would be line and and press tab until you find the snap point, and this, and then connect it here, and LI, and this profile, I guess, as per the AutoCAD plan is not correct. I would like to deselect this particular lines, and this would follow. If you just check in here, then this is following the, yeah, fine. So let me again go back to slot top and LI, and draw from this point and tab and yes, and TR, and join this to this. Wherein for all this, I will just say that define slope uncheck. Only this two will have the define slope check with the degree to be 12 or 15. Yes, and that is what it is here. Edit footprints, and yes, minus 3 foot offset from roof base should be minus 3 foot and 15 degrees. Yeah, so for both of these two lines, I'll just set offset from roof base should be minus 3 foot. And with that, I'll just say that finish and just go to 3D and check. Yes, fine, clear. So now again, go to first floor and select this particular wall. Press, sorry, I say that IC, and select this 1, 2, and 3, and 4, and this 5 walls, and just go to 3D. Sorry, once again, attach top base and attach. Okay, so you see that particular roof has been created, and with that, now you see that this particular point is higher, so we need to flush it. So for that purpose, I will just go to this and base offset from roof -2, and wow, perfect. Okay, no issues. So this is how you create different types of roof in Revit. Okay, I will just close this because we don't need it now, and I will come to first floor again over here, HR, and not first floor, but I need to see the footprints of. So I would just say that yes, first floor is fine, but I would just say that the range level underlay should be plinth level. So with that, I'll be able to see the particular footprints, and for that, I'll just say that slab top, and I'll select this particular roof and just say that CS. And while in that particular, I will just come and say that overhang to, let's say that 2 feet, and just define, let's say that thick walls, and 1, 2, 3, and 4, and TR, and join this to this. But for this two, I will just get rid of the fine slope uncheck. And for this two, I will just add that the plate offset from base to be, for anyone, I will just say that plate offset from base will be 3 foot. Okay, and with that, I'll just finish and just go to 3D. And yes, that's created, but it created at the wrong level. I would just say that first floor. Okay, and I guess that we need to lower it down a bit. So base offset from level, let's say that 3 foot negative. Yeah, fine. This looks better. Minus 18 inches would be better. Yeah, fine. And this chain of walls, this particular first floor, not first floor, plinth level, and this tab and chain of walls come to 3D and just say that attached top base and attach. Okay, fine. So that is how we have created this particular roof. And now the last left is this particular part. So again, I'll go to first floor, and here I would say that select this particular roof and say that CS, that it's create similar. And I would just draw a rectangle first. I would get rid of slope from all the segments. And this, I would just extend till this part. And this move, I will just move this line here and join this line with this face. And herein, I would just move this line to this point. Okay, and create a line over there, but define slope uncheck. And then I would extend this roof all the way to this, the compound wall. Okay, and just TR and join this to this. And now we are going to create punchouts over here. So again, that would be a drafting, clear cut drafting, but that would take a lot of time. So instead, what I would just say that define slope uncheck, I define slope check and 15-degree slope. And I will just go to this particular and just say that edit footprints, and just select this entire thing and just say that's HI. Okay, and select this particular roof and just say that copy. Okay, so that is nothing but just a clear cut drafting. So I would just say that finish and come to this first floor, and here I'll just paste that particular roof. Okay, and from here I would just get rid of this particular line, select all this, and just move it from this point to this point. Okay, so that is how we have created the punch out the roof, but this line is still this edge. Okay, sorry. So first floor, and select this and move it from this point. I guess that there is some problem within this. Move it a bit. Yes, and TR. Yeah, fine. But oh, sorry. I guess that move it from here to this edge, and then TR and join this to this. TR and join this to this. Yeah, that's fine. Okay, and on slope on one end and finish. Why? Lines must be enclosed to. Where is it open? Where is it open? TR and join this to this. Or it's a closed shape. Because so might be problem at somewhere. I couldn't find any open ends. What is the problem? Oh, let me just move this. Oh, yes. Oh, we need to delete this. Yeah, fine. Okay, and that's finished. Okay, so that is how we have created that particular roof, which would be on this portion. Okay. So what I just need to do, I need to go to plinth level, select this walls, 1, 2, and I guess that this should join this with this, and switch order, CC, plinth level, and yeah, it is joined. So why? Okay, 1, 2, and 3, and 4. This 4 walls, I will just say that go to 3D, and with that, I will just say that attach top base, and yes, okay. So with that, now we have created this particular roof. Fine. Let's create the supporting vertical elements at this edge. So that is nothing. Also, just clear cut drafting. So I will just take this particular section over here and go to that particular section, and we can see, oh, this is the roof. Fine. So what we need to do, again, I will just save time since it is a edit in place, and I will just take a profiles, copy the profiles from that, and edit extrusion, and select this particular profile, 2D drafting, so we don't waste time on drafting that particular thing, and just finish. And that would be edit in place, generic model, and just go to that particular section. But I need to select this and PK and select this edge, and then go to that particular section. With this, now I can just go to architecture component, place a sorry, too fast. Model in place and roof, and okay. It will be element of roof, and just say that extrusion, and just copy that particular profiles and just adjust it here according to this. So here, if I just click this here, then you see that the lines are not matching. So what I will do is that I just select this and snap this line. Okay, so now it is matching. You just need to set this to face. Okay, and I was supposed to select move that on lower. Yeah, and with that, I will just select all this line and move. But I would have to trim all this. So just stay tuned, and we'll complete that in a while. Okay, and join this to this. And we are almost done. Okay, and yeah, fine. And so they say that extrusion start 0 and extrusion end 9-inch. That is the thickness of the compound wall. And that would be sloping roof material. And just say that okay, and just finish and go to the 3D. So negative. Okay, and yeah, that's fine. So it tallies. Okay, it tallies perfectly. Only thing is that you need to select this, copy, and finish, and just select this, edit type, edit, and just sloping roof material, and rename it, calling it 6-inch. Apply and okay. So that will be applied to all the roof. So I just put enter. Yeah, that's fine. Perfect. Okay. So now the entire structure is complete. Perfect. The only thing left is manipulating this part, which is slightly, not much, but slightly, it's offbeat. So herein, I will just come to this particular one wall. And if you just closely watch, then you see that this are inclined walls having this punchers. Okay. This inclined wall having this particular punchers within them. So what I will do, if I come to this particular 3D, then you see that I would select this wall, and here you have this definition cross section, which is vertical. I will just turn it to slanted and give it a slope of 15 Okay, so I will just 50 is too much. 5, or let's say that 12. Yeah, that's enough. 12, and is that the same slope? Minus 10. Oh, minus 10 it is. But in this case, it will be just 10. Yeah, okay. So that now we have created this particular wall slant, okay? And now we need to create punchers within this particular wall following this particular slope, and also adjust the profile of this particular roof. Okay, so herein we have to make certain assumptions. For example, if I just take this particular section over here and go to that section, then you see that if this is the slab, this is the width of the slab, then from this end we have to stop at roughly 15 inches. Okay, so I will just come to this particular first floor, and herein I would just select this particular, I cannot see it there. Maybe I need to go to 3D and select this and just go to edit boundary and 15, and yeah, from here I just snap it, come 15 inches. 15 inches, I will make that slab smaller, and yes, okay, and quick sketching or TR and join this to this and finish. Okay, and yes, so with that we have at least resolved this part. Now herein this profile, this wall and this particular wall is not visible, so that's fine, but this wall, at least this wall should say that edit profile, and with that now it should let me just come to section first and take this particular section here, because we have to match that particular wall, and edit profile, and fine, I will just say that li, or let's say that line, select this line and select this tr and join this to this, join this to this, and join this to this. Okay, and just say that finish. Detach target. Okay, that's fine. Okay, and with this now we also have to edit the footprints of this particular roof, because we have to create a flush junction over here. It cannot be open or the water will penetrate inside. And this is the same wall which I was talking about. This would also be, see, HH, and this would also follow the same. Let's say that edit profile. Go to that particular same section, and herein also you need to pick and snap TR and join to this to this. On the same section, we are doing it for the opposite wall. Okay, and just finish and detach target. Yes, that's okay. And just come to 3D. Yeah, fine. So both the walls we have aligned as per this particular sloping wall. Okay, as per the slope. What we just need to do is that we need to adjust this particular roof, edit footprints, and go to first floor and take it slightly inside, roughly. Okay, and don't attach, and then go to 3D. Okay, fine. So it's done. Clear? So this is how you have to deal with some when we are dealing with the sloping angles. Also create sloping roof and such angles you are dealing with. You have to just take care of this and manipulate it this way. Roughly just match it. Actually, I can just go to south elevation and also just match elevation and south. Just match this, move this from this point to this point, and TR and join this to this. Okay, and join this to this, and just finish. Okay, and finish and 3D. Yeah, that's perfect. Okay, now we need to create punchers here. So how we will do that? We can do that here itself in south elevation. So edit profile. Yes, and that removes the top. And again, the same thing you did for here, you have to do it here as well. So pick lines and pick this TR and join this to this, join this to this, join this to this. Okay, and herein there is a, if you remember, there is a balcony. So you need to create an opening for that particular balcony. Yes, okay. And this, I would just like to get rid of this line and offset it roughly 2 feet, or let's say 3 foot. Okay, and just create and get rid of this line. Okay, and that is how we have created this particular wall. And join elements and then just go to 3D. Okay, so see, that particular wall has been created with that punchers. Okay, and you have here you have a little bit of issue. So again, go to edit profile and just go to the section, and this should match. Delete and tr or tr and join this to this. Sorry. Okay, so that is how we have edited the profile of that particular roof wall and matched that with that particular sloping roof. Okay, clear? The same way here also you need to create a puncher. Here it is already that wall doesn't exist. So here you need to create that particular puncher. So I would just come to this particular Plinth level or first floor. Yeah, that's fine. And create a section over here. Okay, and go to that particular section. And herein I will just say that for this particular wall, we have to create a puncher. So I would just say that this can be done a couple of ways. You can create a void extrusion also, but I will just follow this method wherein I'll just say that edit profile. Yes, and that will remove the top base. That's fine. I will just snap it to roughly to the point where this roof intersects this wall. Okay, and herein I will just create a simple puncher at 3 foot from this particular level, and that would be just an assumption. Yes, fine. So this looks better. Okay, and unjoin element, that's fine, but this roof is going on the top of that. So edit profile, and now this would be just an assumption. So roughly we have to adjust this matching this particular wall. Okay, and just go to 3D. Yeah, that's fine. So it is not matching here perfectly, but that's okay. If you want exact, then you have to manipulate a gate in section, but I don't think that it's worth wasting time on that. I think that I hope that you got the concept. So this, I will just match it, tr, and join this to this and finish. So this, I guess that here, so it is not matching. Edit profile, and you have to do it until you get it perfect. And yes, now it's perfect. Yeah, fine. So that is how I have created punchers within this particular slant tapered wall. Okay. So with that, now we are completely done with creating the solid part of this particular, and I will just hide in elements by hide in view by elements. We can properly visualize our project. So with this now, just go to that particular, let me just close this unnecessary views in order to avoid confusion. Just go to first floor, and you cannot visualize that. So slap top. Yes, herein I guess that I can visualize this. So I can just say that on this particular level, we will adjust it later in elevation. And I will just say that wall, and herein curtain wall bridge 2. And I will just create 1 and 2 and 3. And just go to 3D. Let's see where it has been created. Yeah, so didn't I say that we'll adjust it later? So herein, I need to select both of this, and actually all 3 of this. 1, 2, and 3, and not slab top, but first floor with a height base offset of 3 foot, because that intermediate level is at 3 foot, and unconnected 6 foot. So yes, okay, perfect. So this is how, but 6 foot is too much. 4 feet, yeah, that's fine. Okay, clear. So that is how we have laid that particular railing to that particular point. Fine. And now what just we need to do is that CCR enter. What we just need to do is that create the openings and place the openings for this particular entire structure. Here, where there is a corner window that will come, and that would we will create using a special different method, wherein I'll just go to this first floor, and herein first is that I'll just go to this wall join, and herein I'll just say that disallow this join. Okay, so that will disallow the join, and I will select this particular wall and snap it. Select this wall and snap it. Okay, so this has not yet been separate. So again, click this and say that disallow join and click here. Okay, and this should snap here with this line showing that this is no more a join. So I will just go to wall now, and with that curtain wall corner dark glass, I will just draw one wall over here and one over here. Okay, and herein I will select this particular line and just snap it till the exterior edge. Okay, so that is how we have created a corner window over here. Okay, clear. And just select this, and you can drag it to whatever height you want to. So this curtain wall, and just say that unconnected height to, let's say that 8 feet or even more, 12 feet, or 12 feet is too much, 10. Okay, and select this and just say that 10. Okay, so that is how we have created a corner curtain window, a corner curtain glass wall. Okay, on this particular face. Fine. So now what we just need to do is that we need to place openings to this particular project, and with that the entire thing is done. Only thing is that here is this one wall, which I would just like to say that top constraint to unconnected, and just bring it to 20 feet. Yeah, that's fine. Better. Okay. So now what I will do is that I will just go to this particular project here, and it has a lot of 3D elements and 3D windows and openings and everything, which I would just take to that particular project. So I will just select this. This is an existing window of Revit that comes with Revit. You can load it from this library. That is, what is this window? This is window double hung arch head custom. Where can you load it from? Insert, load family, and library is English Imperial US and Windows. And from here, you can just load that particular window. Okay. Now, this is the parametric window, parametric classic window. In order to learn how to create this, you have to enroll for this particular course and learn one-on-one with me. Okay, likewise, this is a window with side light and transom. This is the side light, and this is called the transom. Edit and open that as well. This is existing window. Lures, existing window of Revit. Okay, and this is again a parametric door, that is with door double adjustable swing with transom and side light. Okay, so this also I will just open, edit family, and all this we are going to load into our project. Yes, and this is the sliding folding door, sliding folding with casement and awning window. and also this pivot door. Okay, yes. And is anything left? Fine. This, I guess, that corner, angled curtain wall. This I have already, just let me check. Wall and angled curtain wall. Yeah, this is there, but does the family copied? Yes, angled curtain wall, it's copied. Okay, so with this now we will start. But let me just load all these particular families into the our newly created project, project one, and okay. Yes, I will just close it. Next is this parametric classic window. Okay, close it. Next, window with side light and transom, casement and awning window with side light and transom. And no, this would be the louvers. Okay, which exists within the library of Revit. This is load, door, double adjustable swing, parametric door, and this will take a bit of time. Heavy door it is. So we are going to place it here. Internal conflict with the wall, we will later adjust the constraints. That's fine. And this is the sliding folding casement and awning. Sliding folding door with casement and awning window. So load it into project. And that we will place it on here. Okay. And let me just get rid of the sunshade. Okay. Since it is covered with a roof, overhang roof. Okay. And just open up this windows. 3D awning window 45, casement window 45. Okay, and herein I will come to this particular door. Does that door exist here? Yes, it does. Type B, and here is the casement and awning window. So let me just close this. No. And herein I'll just flip, and this is the type B, the smaller size, and it will fit within that opening. Yes, and I guess that we need to shift it a bit. Okay, and yes, okay, and just say that this materials is sash, the existing material of Revit. So I'll assign it to all the instance parameters. Take a bit of time to regenerate the very heavy door. Complete parametric door it is. Control V, and let's say that Control V. Okay. And here to one last instance parameter, vertical blade material. Control V. Yes, fine. Okay. And then WN, and I will look for that casement and awning window. Yes, sorry, not casement, a window with side light and transom. So this too, I will just load it on this particular wall and give it a height offset of level first floor and height offset of 15 inches only. That's enough. And just get rid of this particular sunshade. And yes, so it's having conflict with the roof. So we need to lower it down a bit. 9 inch. Uh-oh. 9 inch. Yes, fine. So that will perfectly adjust within that particular wall. Okay. So likewise, now we need to create that particular door, the same door here as well. And now I know that herein, yes, fine, perfect. Okay. So let's check that if anything exists within this face. No. Here also the same two door windows. So this will be done very smartly. I will just select both of this and just say that copy to clipboard and paste align to selected levels to plinth level, and that will jump to that particular level. Okay, fine. And herein now we have to lay the louvers. Also, we have this window over here as well on this face. If you just check, then here, yeah, we have this louvers and this particular one window here. So I will just come here and just say that select this particular window and CS and snap it here on this particular wall. Okay, and for this I would just say that sunshade to be on, so the instance parameter. Okay, and now I'll just say that WN, and I will select this particular louvers 24 cross 24. I'll place it one over here and place it one other over here roughly. Then I will go to plinth level and adjust its location. Yeah, fine. Its height 6 feet. Okay, and come to first floor and to 6 feet as well. Okay, and go to 3D. Okay, and herein I will just say that WN and that classic window, classic parametric classic window, I will just load it on this particular face. Okay, and here it is. Fine. Is anything left? Yeah, here is the small windows, fixed windows, 16 cross 24. This edit family, and oh, that exists within the library of Revit. So you can just load it by saying WN and WN and that fixed window. Here it is. 16 cross 72, and I'll just load and go to 3D. Yeah, fine. See, okay, and just one and copy one more, 1, 2, and 3. Okay, that's fine. Where else? Now we need to place the angle curtain wall. So wall and angle curtain wall, it is having that particular parametric family, angled curtain wall. So herein again, I need to say that wall join, select this, disallow join, click, and select this from this end to this end, and this, all this wall I will just separate. And this is a special way of laying the curtain walls. Angled curtain wall and 9 inch and unconnected height. 7 foot 6 inches. No, but it should be in a multiple of 2 because it has been designed that way. So 6 inch and 8 foot 6 inch. Okay, so that would make its unconnected height 8 foot. So herein I will just come here and make it a round figure, which is the multiple of 2. Let me first just create one and delete type. Go to 3D. It has created, then why it is saying that cannot create? flip the direction. Yeah, fine. And I say to the multiple of 2. So select this and just say that plinth level and 6 inch and unconnected 8 foot 6 inches. So that would make it height 8 foot. Then what is the problem? 6 inch. Let's get rid of 8 foot. Yeah, fine. Okay. And CS and create one more over here. And that should again be only 8 foot. Okay. And just select this and move it from this point to this point. And move this from this point to this point. Okay. Yes. So 3D. And yes. But we need to have a flush connection. So just select this and just okay. And this particular thing, I would think that 8 foot is enough. Oh, then why it is deleting? So delete and just wall and the curtain wall again from here to here. Let me first draw here to here. Yes, and just select this and drag it all the way. That's fine. Move it from this point to this point roughly. Okay, let's not waste further time on that, but you have to manipulate it. Then only you will perfectly able to snap. Yes, okay, fine. And go to 3D. Yes, okay. Just flip the direction. Yes, okay, perfect. So angled curtain wall I have laid, and with that, I guess that here also there is, yeah, see here also the same angle curtain wall do persist. So I would just go to first floor and just go to wall joint, disallow joint, disallow this, snap, okay, WA, and that same angle curtain wall, but this time I will just snap it 4 feet, okay, and this would be 4 feet and multiple of 2, yeah, and this I would just take it here, but that's adding the panels. Let this be 4 feet. Press tab. Actually, I've forgotten right now the way how to flush this and have a flush connection. Sorry about that, guys, but let's not waste further time on that. And 4 feet. Okay, and just go to 3D. This should here, and this wall shouldn't come. So yes, okay, and 3D. Yeah, okay, fine. Not worrying about the exact joint condition right now. And with that, now we are completely done. Except for this one main door is remaining, I guess. No, here there is no door. But here there are windows. The blue end and that particular arch window that I made a part of this custom. Yes. One over here and another next to it. Okay. What is the sill height of that? 1, 2, 3 foot. Plinth level, 3 foot. So 1 and 2 and plinth level and 3 foot. Okay. And also I have some fixed windows over here so that I can just quickly WN and fix window. any of this 1, 2, and 3. Wherein 1, 2, all of this 1, 2, and 3 should have the same cell height, 15 inches from plinth level. No, 3 foot. The cell should match. Okay. So that is how we have created. And on plinth level, here there should be a door. But in order to place host a door, you need a wall. So CS, CS, and create one wall. Okay. Plinth level up to first floor, that's fine. And just host a door over there, which would be this parametric doors wouldn't occupy. So we have to create this simple door. Okay, and just go to 3D. Okay, fine. So that is how we are completely done with the laying of this particular doors and windows. Now, in order to create this particular road, this is nothing. It is just a floor type which has been assigned the material of earth, which is the existing material of Revit. Okay. So, and this also has been created with the same way, floor, a road, but it has been applied that material. Okay. So this I will just say that select this entire thing, and these are the existing libraries of Revit, this trees and this human figures, cars, everything. Where can you find it? I'll just go to insert and load family. And herein, under this library, English Imperial US, under entrage, you will find this car beetle. Then you will find this male, female. Okay. Rest other thing. The trees and plantations are in the existing library of Revit, which you can just say that architecture and component. And from here, if you drop down, you'll be able to find, host all these particular different types of trees and the shrubs and everything. Okay. And the street light, I will just go to insert and import load family and English Imperial and US. And under lighting, under architectural, external, you'll be able to find your street light. Okay. Clear? So what I will do is that I will just select this entire thing, which is the group, and also this road, also this arrows. Oh, sorry. Select all of this. Okay. And just say that copy, and just to save time, I will just go to site, and onto the site, I will just paste this particular elements, and I will just move from this point to this point. Okay. And just go to 3D in our project, and you see that everything has been hosted at its point where it is supposed to be. And this is how we have created this particular entire project. So just watch this video and get up to this particular point and let me know if you have any doubts or queries. You can lay down your doubts and queries in the comment section. And if you think that this particular video was worth, then kindly enroll for this particular course, and let's learn together and let's go together. And all the best, and see you. Bye.